Everybody, welcome back to Anantha Lakshmi Academy. As promised in the earlier video, today we are going to discuss the last exercise of trigonometry 11.4, and this exercise is based on the trigonometric identities concept. As mentioned earlier, I hope you guys must have gone through the examples so that you feel that the exercise problems are a bit familiar. All right, so let's get started. Let's solve the first bit in the first problem. Here it is given as 1 plus tan theta plus secant theta multiplied with 1 plus cot theta minus cosecant theta. Okay, let me substitute the values as is, like 1 plus sine theta. What is tan theta? Sine theta by cos theta. And secant theta is 1 by cos theta. Close the bracket. Cot is cos by sine, right? Cos theta by sine theta minus cosecant is 1 by sine theta. So here 1 plus, adding these two fractions. So this becomes 1 plus sine theta by cos theta. And this becomes 1 plus cos theta minus 1 by sine theta. So consider the LCM and take it the other side, like cos theta plus 1 plus sine theta by cos theta multiplied with, what happens here, sine theta plus cos theta minus 1. The LCM part, I hope you guys are familiar by now, right? So what is this? If you consider this, okay, let me restructure it, like sine theta plus cos theta plus 1 by cos theta and sine theta plus cos theta minus 1. By sine theta. All right, how is this? If you consider sine theta plus cos theta as A and 1 as B, A plus B into A minus B is nothing but A square minus B square, which is nothing but sine theta plus cos theta whole square minus 1 by, this is the sine theta cos theta. So what is sine theta plus cos theta whole square? A plus B whole square is nothing but sine square theta plus cos square theta plus 2 sine theta cos theta minus 1 square is nothing but 1. And this is sine theta cos theta. Okay. In the earlier video, we have figured out 3 trigonometric identities. What is the first one? Sine square theta plus cos square theta is 1. Alright. So this becomes 1 plus 2 sine theta cos theta minus 1 by sine theta cos theta. So 1 and 1 gets cancelled. Sine theta cos theta in the numerator and denominator gets cancelled. The answer is 2. The first bit answer is 2. So what we have done in this problem, we just expanded the trigonometric ratios. What is tan, what is secant, cot theta and cosecant theta. A plus B whole square multiplied with A minus B whole square. Sorry, A plus B into A minus B, we have extracted it as A square minus B square, and within that we have used one of the trigonometric identity and the result is 2. So let's get to solve the second problem. What is the second problem? Sine theta plus cos theta whole square plus sine theta minus cos theta whole square. If you look at this, this is in the form of an identity, A plus B whole square plus A minus B whole square. So what is A plus B whole square plus A minus B whole square? What happens? 2AB gets cancelled. 2 into A square plus B square. Alright, it's the same thing. I'm just giving you a hint over here. If you expand this in the form of A plus B whole square and A minus B whole square also, you'll get the same in the form of 2 into A square plus B square. Okay, again, this is a trigonometric identity. What is this? This is nothing but 1. 2 multiplied by 1 is 2. I'm just giving you a hint for the second and third problems. For the first one we have solved. Okay, this is how you need to solve the second problem, second bit in the first problem. All right, if you look at the third one, secant square theta minus cosecant square theta minus 1. In the last session, when we are discussing the concept of the trigonometric identities, for the last two identities, what I have said, if you get the other one on the other side, secant square theta minus 1 becomes tan square theta, and cosecant square theta minus 1 becomes cot square theta, right? Let me show you that. What we have figured out is secant square theta is equal to 1 plus tan square theta. So if you get this 1 this side, what does it become? Tan square theta is equal to secant square theta minus 1. That's the same way for cosecant square theta minus 1. It's nothing but cot square theta. Tan square theta multiplied by cot square theta. Cot is nothing but 1 by tan. They get cancelled and answer is 1. Again, I am not solving this here. You are supposed to solve this, because if I keep on solving everything, I'll be getting everything. You will not get anything. Okay, I just gave you the hint on how to use the identities in the second and third bits. All right, let's get to solve for the second problem. So for the second problem, show that cosecant theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. So let's get to solve this. Consider the LHS part. Solution: LHS is equal to cosecant theta minus cot theta whole square, right? So what is this? A minus b whole square. Expand this. Cosecant square theta plus cot square theta minus 2 cosecant theta cot theta. So this is where we have reached. But cosecant square theta plus cot square theta, do we have any identity? No, we have an identity for cosecant square theta minus cot square theta. So can we solve this from here going forward? No, right? Okay, let us try it in the other way. Like, so how can we write cosecant square theta? 1 by sine square theta plus, what is cot square theta? Cos square theta by sine square theta minus, what is 2 cosecant theta sine theta, cot theta cos theta by sine theta. Here all of them are going to get multiplied. Okay, 1 plus cos square theta by sine square theta. Okay, even this one is sine square theta. So minus 2 cos theta. Okay, now from here on, if you look at this equation, 1 plus cos square theta minus 2 cos theta. If I consider 1 as A and cos theta as B, 1 square plus B square minus 2AB. It is in the form of A minus B whole square. Alright, so this becomes A minus B whole square by sine square theta. Now, so 1 minus cos theta whole square by sine square theta. But here, if you consider this guy, 1 minus cos theta by 1 plus cos theta. They are asking us to prove the denominator also in the form of cos. So, how do we convert sine to cos? Using trigonometric identity. So, what is sine square theta? Sine square, okay, let me write it here. 1 minus cos theta whole square by, what is sine square theta? 1 minus cos square theta, isn't it? Why? Since cos square theta plus sine square theta is equal to 1. What is this? The first trigonometric identity we have learnt. Alright, so this becomes 1 minus cos theta whole square. Okay, come here. 1 minus cos theta whole square can be written as 1 minus cos theta into 1 minus cos theta. If you look at the RHS, we have only 1 minus cos theta. So I am just splitting it by 1 minus cos square theta. How can I write 1 minus cos square theta? If you consider 1 as A and cos is b, this is in the form of a square minus b square, which is nothing but a plus b into a minus b. A minus b multiplied with a plus b. So what happens? 1 minus cos theta, 1 minus cos theta gets cancelled, and the solution is 1 minus cos theta by 1 plus cos theta, which is equal to RHS. LHS is equal to RHS, hence proved. So in trigonometry, all of the rest of the exercises are quite simple, but 11.4, when you are dealing with trigonometric identities, it is, many of the students come to me saying that, see, if you see here, I have expanded this. And how do we get an idea of writing this in the form of trigonometric ratios? And how do we get this idea of writing sine theta in the form of cos? How? It's just quite simple, especially for the show that problems. For show that problems, they will give you the LHS along with the RHS. See, while solving the LHS, what have I done? I just expanded this formula. Okay, here I haven't written, since you guys have to make sure when you are writing in the examinations, a minus b whole square is equal to a square plus b square minus 2ab. Since therefore, these are the things which students must have to use. Okay, here what have we done? We just expanded this formula, and from here, even using the identities, we cannot solve this because we do not have any identity as per in this terminology. So what have I done? How do we simplify this? In order to get, we finally have to go there and prove this. So what have I done? Okay, if this is not coming in this way, let's go in the other direction. That is by using the trigonometric ratios. That is 1 by sine square theta. How can we write these words in the form of simple things? That is one thing which you have to remember. And there is no solution in the form of cosecant cotton, right? So that is, it is indicating that your solution, the driving solution, should be in terms of cos and sine. So this is nothing in the form of cos and sine, right? So I have simplified this. Now 1 plus cos square theta minus 2 cos theta. How did you get this idea? Okay, so for this, if you consider this, 1 minus cos theta is something which we have to get in the numerator. So how do we get this? If you think like this, you can go to this. And sine square theta, how do you remember to write it like 1 minus cos square theta? That is because the denominator is also having 1 plus cos theta, right? So that is how we need to solve a problem depending upon the RHS. And now how are we going to simplify? When you are stuck somewhere, do not look for somebody else to solve the problem. It's just that if we are not able to get the answer in this way, why can't we try it in the other way? That's the thing. All right, let's jump into the next problem. The third problem, show that under root of 1 plus sine a by 1 minus sine a is equal to secant a plus tan a. This is also the same technique which we need to use. It is LHS and RHS. When you have LHS and RHS, we need to make sure that, so this is in the form of sine, but they want the answer in secant and tan. All right, so let's try to solve this. So how do we solve 1 plus sine a and 1 minus sine a? This cannot be solved anymore. Okay, let us multiply numerator and denominator with under root of 1 plus sine a. Okay, let's do this. 1 plus sine a by 1 minus sine a multiplied with under root of 1 plus sine a by 1 plus sine a. This is also under root. Okay, so what happens? 1 plus sine a, 1 plus sine a becomes 1 plus sine a whole square by 1 minus sine a into 1 plus sine a is nothing but a square minus b square, 1 minus sine square a. What is 1 plus sine a whole square? Okay, let me write it here. Now 1 plus sine, let me split the roots. 1 plus sine a whole square by 1 minus sine square a. Trigonometric identity number 1, cos square a, right? What is that? Cos square A plus sine square A is equal to 1. And hence 1 minus sine square A, if that sine goes that side, it becomes cos square A. This and this gets cancelled. 1 plus sine A by cos A is equal to 1 by cos A plus sine A by cos A. Why did I split this? Because the RHS is not in the form of sines and coses, it's in the form of secant and tan. So this becomes 1 by cos is secant A, sine by cos is tan A, nothing but RHS. This is equal to RHS. LHS is equal to RHS, and hence proved. If you look at this problem, we couldn't simplify this anymore. So what did we do? We just multiplied the numerator and denominator with under root of 1 plus sine A. Because, okay, and then we just multiplied, and with that we got 1 plus sine A whole square by 1 minus sine square A, but the RHS is in the form of secant and tans. After the cancellation, we just split the fractions and we got the result. Alright, let's jump into the next problem. So for the fourth problem, we have a show that 1 minus tan square A by cot square A minus 1 is equal to tan square A. So let us solve the LHS part first. 1 minus tan square A by cot square A minus 1. First thing we need to look for is, can we use any identities here? No, because 1 plus tan square A is 1 and 1 plus cot square A is cosecant square, right? So we cannot use trigonometric identities here. So how can we expand this? This is a form of a square minus b square if I consider 1 square. Cot square A minus 1 as cot square A minus 1 square. So that becomes a plus b into, a minus b multiplied with this, and cot A minus 1 and cot A plus 1. So we have tans and cots. We could not simplify this, but can we write cot in terms of tan? Yes. How? That's just the multiplicative inverse of tan. 1 minus tan A by 1 plus tan A by 1 by tan A minus 1 and 1 by tan A plus 1. So what does this become? If I consider 1 minus tan A, 1 plus tan A, this becomes 1 minus tan A by tan A, and this is 1 plus tan A by tan A. Alright, so this is a fraction in the denominator. The denominators gets to move the upside or the, okay, so that way we have continuation here. 1 minus tan A, 1 plus tan A. The denominator part of the denominators of the down fractions are going to come here. That is nothing but tan square A by, what is it? 1 minus tan A and 1 plus tan A. The denominator in here has come upside. Okay, 1 minus tan A, 1 minus tan A, 1 plus tan A, 1 plus tan A gets cancelled, and this is tan square A. That's nothing but RHS. LHS is equal to RHS, and hence proved. Alright, so let's jump into the next problem. So for the fifth problem, we have show that 1 by cos theta minus cos theta is equal to tan theta multiplied with sin theta. Alright, so let's get to solve the LHS part first. 1 by cos theta minus cos theta. If I take the LCM, this is going to be cos theta. 1 minus, this goes this way, cos square theta. Cos theta multiplied by cos theta. Here comes the trigonometric identity 1 minus cos square theta. is nothing but sine square theta by cos theta. Because sine square theta plus cos square theta is equal to 1. Alright, so sine square theta by cos theta is what we got, but the RHS seem to be tan theta and sine theta. So what can we do? Tan theta is nothing but sine by cos, and sine theta is sine theta. Okay, so how can we derive this? If I split this square into sine theta into sine theta by cos theta, you consider this guy tan theta and sine theta. This is nothing but equal to our RHS, hence proved. Let's jump into the next problem, problem number 6. So sixth problem, they are asking us to simplify secant A multiplied with 1 minus sine A and multiplied with secant A plus tan A. What is this? Simplify, simple terms. In simple terms we need to solve this. So let's try doing this. First let me take secant A into this bracket. Secant A minus secant A into sine A and secant A plus tan A. So what is secant A and sine A? Secant is 1 by cos, but sine is sine. If sine and 1 gets multiplied, this becomes sine A by cos. So secant A can be written as 1 by cos A, and this becomes sine A by cos A. Secant A minus sine A by cos A is tan A. This is secant A plus tan A, which is equal to A minus B into A plus B, secant square theta minus tan square A. This is the second trigonometric identity we have derived, nothing but 1, since secant square theta minus tan square is equal to 1. So this is about problem number 6. So what have we done for problem number 6? We just took the secant inside and tried converting secant into sine into tan. That way it became A minus B into A plus B. Here A minus B into A plus B is equal to A square minus B square. Okay. For that it became the second trigonometric identity which we have derived, which is nothing but secant square A minus tan square A, and which is equal to 1. That's all for the sixth problem. So for the seventh problem, sin A plus cosecant A whole square plus cos A plus secant A whole square is equal to 7 plus tan square A plus cot square A. If you simplify the LHS part, we should be getting this part. Okay, so let's prove that. Consider the LHS A plus B whole square plus A plus B whole square, right? So LHS is equal to sin A plus cosecant sin square A plus cosecant square A plus 2 sin A cosecant A. What is sin A multiplied with cosecant A? Sin A cosecant A is nothing but 1 by sin A. Sin A gets cancelled. Alright, plus cos square A plus secant square A plus 2 cos A secant A. So here sin A cosecant A is nothing but sin A by sin A, which is 1. Alright, sin A cosecant A is 1. In the same way, cos A secant A is nothing but cos A by secant is 1 by cos, which is also 1. Okay, this is our since condition for the next one. Okay, here sin square A plus cos square A, I have taken these two, plus cosecant square A plus secant square A. Is equal to sin A cosecant A is nothing but 1, cos A secant A is nothing but 1, 2 plus 2. So how many numbers we got? 2 plus 2 is 4. 4 plus, what is sine square A plus cos square A? This is nothing but 1 plus cosecant square A plus secant square A. Alright. Okay, let me put it like cosecant square A plus secant square A. We got 5 now. 5 plus cosecant square A plus secant square A. There is no other way I get a 1 here and get 7. But the RHS seem to be in tan and cot, but not in cosecant and secant. For this, we have the trigonometric identities. What is cosecant square A? Is nothing but cosecant square is 1 plus cot square A plus secant square is 1 plus tan square A. So 5 plus 1 plus 1 is nothing but 7 plus cot square A plus tan square A. This is nothing but RHS and hence proved. What have I done here? I just expanded this form and sine A cosecant and cos A secant is 1. That's what we have substituted and we got 4. Then we have used the first identity sine square A plus cos square A is equal to 1. Later on we just got 5 plus cosecant and secant. But here it is 7 plus tan and cot. So in order to write cosecant and secant in the form of tan and cot, we have used the trigonometric identities. 1 plus cot square A is equal to cosecant square A and 1 plus tan square A is equal to secant square A. This is the second and third trigonometric identities which we have derived in the earlier video. Alright, this is about the problem number 7. Let's jump into the next problem. So for the 8th problem, we have 1 minus cos theta multiplied with 1 plus cos theta and 1 plus cot square theta. We are asked to simplify this. Alright. So 1 minus cos theta and 1 plus cos theta is in the form of a minus b into a plus b, which is 1 square minus cos square theta multiplied with 1 plus cot square theta. What is 1 plus cot square theta? Cosecant square theta. This is the trigonometric identity which we have derived. Because 1 plus cot square theta is equal to cosecant square theta. Okay. So this becomes 1 minus cos square theta into cosecant square theta, which is nothing but 1 minus cos square theta is nothing but sine square theta multiplied with cosecant square theta is nothing but 1 by sine square theta. This gets cancelled and the answer is 1. So here what have I done? I have used the first trigonometric identity. Sine square theta plus cos square theta is equal to 1. It's just using the identities. Here for understanding purpose, I just wrote it with the arrow mark while copying or while writing in the exams. Please do not do this. You just write it like 1 plus cot square theta. Okay. This is about problem number 8. Let's go to problem number 9. So for the 9th problem, we have secant theta plus tan theta is equal to P. Then what is secant theta minus tan theta? Alright. So what is the second one which we have derived? The trigonometric identity. As per the trigonometric identity, secant square theta minus tan square theta is equal to 1. Isn't it? This is the same thing which we have derived. If you remember, since 1 plus tan square theta, we derived it as secant square theta. Alright. This, I just took tan to the other side. So this becomes secant square theta minus tan square theta is equal to 1. So now the question comes up. Here they are asking us in secant theta plus tan theta is P. What is secant theta minus tan theta? Why are you getting this identity into this? Because if you look at here, they are asking, they have given you something and they are asking you to figure the other way around of it. So how can I solve this? What can I do with secant theta plus tan theta is equal to P? Even if I substitute the trigonometric ratios, simplify trigonometric ratios, I couldn't get this value. So what am I doing? Trigonometric identity, the second trigonometric identity which we have used, and I took it to the other side. Why did I take it? Let us know. So this is in the form of a square minus b square. This is nothing but a minus b into A plus B. Aha! So here we are. We know what is secant theta plus tan theta, and we are to figure out secant theta minus tan theta. Right? So what is secant theta minus tan theta? Is equal to 1 by secant theta plus tan theta. What is secant theta plus tan theta? Here it is given. Secant theta plus tan theta is nothing but 1 by p. Since given that secant theta plus tan theta is equal to p, what is secant theta minus tan theta? There is no rocket science or magic in this. They have given one value, they are asking for the other value. We know our identity which is in terms of those two. I just used it, simplified it. Okay? Alright, let's jump into the last problem. So here is the last problem in this exercise. If cosecant theta plus cot theta is equal to k, then prove that cos theta is equal to k square minus 1 by k square plus 1. So how do we solve this? Again, the same trick which we have used for the problem number 9. So, solution. So if cosecant theta plus cot theta is equal to k, then let me use, according to the trigonometric identity, what is the identity which we have derived? Cosecant square theta minus cot square theta is equal to 1, which is cosecant theta minus cot theta, cosecant theta plus cot theta equal to 1. What is cosecant theta? Okay, let us consider this as equation 1. What is cosecant theta minus cot theta? Cosecant theta minus cot theta is equal to 1 by k. Let me consider this as equation number 2. What is the equation number 1? What is given in the problem? Cosecant theta plus cot theta is equal to 1. Now, if I do equation 1 plus equation 2, which is nothing but cosecant theta plus cot theta, cosecant theta minus cot theta. What am I going to get if I am doing the addition? 2 cosecant theta is equal to k plus 1 by k, which is k square plus 1 by 2k is cosecant theta. Okay, let me call this as equation number 3. Okay, so we have done 1 plus 2. Similarly, let's do 1 minus 2. Now the question comes up. What are we trying to do? We got cosecant theta plus cot theta is equal to k. Why are we doing 1 plus 2 and 1 minus 2? Because look at the RHS of what we are supposed to prove. It is in the form of k square minus 1 and k square plus 1. When will you get k square minus 1? When you do the subtraction between the first and second equation. That is the reason we are doing 1 minus 2. Alright? Now, 1 minus 2 is nothing but cosecant theta plus cot theta is equal to k. Cosecant theta minus cot theta is equal to 1 by k. So what happens for the subtractions? The symbols get changed. Alright? This we all know, right? Cosecant theta gets cancelled. Now this is 2 cot theta is equal to k minus 1 by k, which is nothing but cot theta is equal to k square minus 1 by 2k. Let me call this as equation number 4. So what have we done so far? Whatever is given, we consider it as equation 1. We derived cosecant theta minus cot theta as 2, and we did 1 plus 2 and 1 minus 2 to get k square plus 1 and k square minus 1. Now, but we want k square minus 1 by k square plus 1. So how do we do this? If we divide 4 and 3, are we going to get k square minus 1 by k square plus 1? Yes. So let's do that. Divide equation 4 with equation 3. So what happens? Cot theta by cosecant theta is equal to k square minus 1 by 2k by k square plus 1 by 2k. 2k gets cancelled. K square minus 1 by k square plus 1 is what we got. Now we have cot and cosecant, but we need in terms of cos. So let's write it like cos by sine by 1 by sine equal to k square minus 1 by k square plus 1. Sine and sine gets cancelled off and we get cos theta is equal to k square minus 1 by k square plus 1. Hence proved. Okay, so what have we done? If you look at the equation and the first thing that comes to students' mind is that what is this? Cosecant theta plus cot theta is equal to k. How can I achieve k square from this? Just think logically. They have given one thing, you know the trigonometric identity. You can get the other value like 1 by k. In order to get k square, we just need to either add them or subtract them. So we just added them and subtracted them. In order to get this fractional part, we just did the division. Alright, so this is about the last problem in exercise 11.4. With this, I'm going to close the chapter trigonometry. So Anantha Lakshmi Academy has successfully finished the 10th class trigonometry chapter. After this chapter, we have applications of trigonometry, which is like a continuation part of this. So that just has 2 exercises. For many of the people, they think that earlier it used to be called by the name heights and distances. Now it is called as applications of trigonometry. Once we are done with this, probably we should be finishing that even before we jump into the next chapter. So I'll be covering that as well, applications of trigonometry. I got a request from one of the viewers asking me to cover from the first chapter as well. So I don't remember the name of that particular viewer, but yeah, for you I'm telling, once applications of trigonometry, which is the continuation of this chapter, is done, that just has 2 exercises. It should be done in a very less time. Once that is done, I'll start from the real numbers, the very first chapter of the 10th class. Why I have picked up trigonometry is because many students have come to me saying that trigonometry is such a big chapter, such a complex chapter. So I thought, let me start with trigonometry so people feel comfortable and familiar with Anantha Lakshmi Academy. So if you look at the way I am teaching and you get to know how I am teaching the very tough chapter, you get to know whether am I able to make you guys understand or not. So for that purpose, I have picked up trigonometry, and now that we have finished it, and we will be opening up for the doors for our applications of trigonometry in the next videos. All right, once that is done, we can get started from the other chapters. So if you really want me to explain or solve any of the problems or any of the chapters, do please let me know by commenting. Write a comment saying this is what we need, this is what we are not getting, or this is what we are not understanding, so that I'll take a look and I'll try my best to simplify the solutions for you. All right, so if you finally the subscription request, if you feel that the content is worth enough, please do like, share and subscribe to Anantha Lakshmi Academy. There is no physical form for this academy. If you want to join in this academy, just click on the subscribe button which you see under the video, which will be in the red color. So just click on that so that you get to know when I upload any video of any chapter. All right, so thank you.